Good morning, lesson 5-3. Today is a long one and there's going to be some notes, so pause and go get a piece of paper. You're going to need it and you're going to want to be able to use it later. So we're going to learn how to write algebraic expressions. Remember, expressions do not have an equal sign. No equal signs, okay? Yesterday we worked on numerical expressions and using our order of operations. Today we'll use the order of operations, but we'll have some algebraic expressions. We're going to have to go through all the pieces that can be in an algebraic expression. First one you have is a term. So if we had, let's put an example 1 down here. If we had an expression that said 4x plus 12 minus 2x, in this expression, 4x is a term, 12 is a term, notice it's a positive 12, and negative 2x is a term. This sign must go with the term. In this example, we have a variable. The variable is the x. There's no other variables, there's no other symbols we don't know. The coefficient is the number in front of the variable. So here you have a 4, and we have a negative 2. The constant is just the number, no variable attached, so it's a term that is only a number. In this case, we have 12. Now, are there any terms that are alike or have the same variable or no variable at all? Well, in this case, we have 4x and negative 2x that are same. Okay, let's do another example. Let's have example 2 be 6n plus 7n plus 4 plus 2n. Okay, what are the terms? 6n is a term, 7n is a term, 4 is a term, and 2n is a term. Okay, those are what the terms are. So we could probably say that a term is sort of like something you use an operation with. Honestly, I think the examples are better than a definition in this case. Okay, let's look at the variable. In example 2, what's our variable? Yeah, the n. The n is the variable in example 2, and the variable is a symbol or letter whose value can, doesn't have to, but can change, because the word variable has vary in it, and vary means to change. Okay, let's look at the coefficients down here. Remember, the coefficient was the number in front of the variable. Oh, so the 6, a 7, there's no variable here, there is a variable here, so the 2. All right, so our coefficient, the number with the variable in a term. All right, and constant. What's a constant? Well, the constant was just the number, boom, 4. And its value stays the same. A number with no variable, value stays same. Constant means stay same, basically. And then like terms, Well, all these things that have n's, 6n is like 7n is like 2n. How do you figure out like terms? Well, think of the n as like an actual little tiny n you could hold in your hand. And if you had 6 of them and you added 7, now you'd have 13. If you add 2 more, you'd actually have 15 n's. That's what that means. Here's a bonus. If you have just a variable, just the variable y, there's an implied 1 in front of it. We don't write the 1 because it's extra work, but it means 1n, and if that's the case, that's a coefficient. So in example 3, that would be the coefficient. In example 3, the variable would be y, the only term was y, and there were no constants, and there are no like terms. There's only one term. Okay, but 1y is just y. So if you ever see a variable all by itself, the coefficient would be 1. Okay, so let's use that information. And, well, we worked through 3 examples, so now we've got some other information to add. Addition, subtraction, multiplication, division. Remember, if I write, you write, so you're going to be kind of making this. Pause if you need to. Symbols that mean addition. Usually that. Symbols that mean subtraction. Usually this. Multiplication, we can't use an X anymore, but we can use an elevated dot. I'm going to write some examples here. 5 times A could be written like this. You could do 5 times A. A number next to a letter means multiply. A letter next to a letter means multiply. But a number next to a number just means a bigger number. You could have parentheses. You could even have double parentheses. Okay, those are symbols that mean multiply. And symbols that mean division, a division bar. You might have a goes into box, 15 divided by C, 15 divided by C. You might have 15 divided by C. Sometimes on your calculator you have a slash, and it would look like that. Let me make sure I got all the examples the book had too. Oh yeah, they only had 2. So we're way ahead. We're way ahead. Okay, so those are some symbols we might need. What are some words that mean add? If you have increase, more than, and sometimes means add. Subtraction, minus, obviously subtraction, less than. Less than turns out to be a tricky one. Over here you could have the sum, which is the answer when you add. You could have the difference, which is the answer when you subtract. For multiply, you could have product times. Product is the answer when you multiply. There's some other ones we can get to there later. Division, the word quotient is the answer when you divide. Sometimes groups of means to do division. Okay? This is how we're going to start translating English into Mathlish. We have to know the English words, recognize them, and then that tell us what we need to do. You've been practicing this for a very long time. I know this video is getting long. We'll try to do our best. Okay, so over here, let's just skip down here to the check. Define a variable that represents the unknown in the phrase $12 less than the original price. Well, I'm going to use P as my variable. That's part of defining the variable. Now let's go back in here. the phrase $12 less than. Ooh, less than. That's on our list. Less than means to subtract. Okay, that's on our list. So less than means we have to subtract 12. If you're going to subtract 12, you have to subtract it from something. So that's why the P came first, even though the word 12 came first. Because it's 12 less than P, which means 12 has to be less than something. I told you it was going to be tricky. Define a variable to represent the unknown in the phrase 6 times more money than Elliot saved. Well, could we use E for our variable? And 6 times. Oh, that's multiply. So we have to have 6 times E. Remember, lots of ways to write that. You can just have a number next to a letter, and that will totally work. So I'm going to use this one. If you use this one, the number comes first. You can write E6, but in algebra land, we like the number to come first. Let's go over here to page 283. Define a variable to represent the unknown phrase 2 less than. We just learned 2 less than means minus 2. 1/3 of, let's add that to our list. Multiply. The word of, remember, meant to multiply. We've done that before. 1/3 of the points the Panthers scored. 2 away from 1/3 of the points the Panthers scored. I know it's complicated. This is going to take a little bit of work. Okay. This one, to find the perimeter of a rectangle, to find the perimeter, or all the way around a rectangle, you have 2 widths, 2 lengths. So you'd have width plus length plus length. Okay? In this problem, it says a rectangle has a length that is means equals, twice the width. Twice is times 2. Width would be our variable. So every L is going to be 2W. So instead of writing an L, 2 width. 2 width. And then how many W's do we really have? More than 4. I have 2 of them here. Plus 2 of them is 4. Plus 1 is 5. Plus 1 is 6. Be really 6 W's. Would be the perimeter of that rectangle. All right, good luck. Be sure you're asking questions.